Hi and welcome to this video about the KNX Modbus TCP Gateway 716 Secure from Weinzierl. In this video I'll show you the setup process of the device, and we'll also take a look at some fundamental things about Modbus TCP in general. But before we do that, let us quickly take a look at the hardware of the gateway itself. As you can see here, the device is pretty small, only has a width of one circuit breaker. And that's because, well, the device only needs a KNX connection. So on the top you can see the KNX terminal, and on the bottom we have the Ethernet connection with the RJ45 connector. Yeah, and besides that we have some status LEDs and some buttons on the front. And that's basically already the hardware of the device. So then let's take a look at the software of the device. If we use the gateway in master mode, this meaning that we use the device to get data from Modbus or to send data to slave devices, then the gateway can connect to up to 5 slave devices. And we can have up to 250 data points. As you might have already guessed it, we can use the device also in a slave configuration. This means that another Modbus TCP master can connect to the device and requests or send data to the gateway. As we have here also an RJ45 connector, it's pretty convenient that the Modbus TCP gateway can also be used as a tunneling interface, and there it supports up to 8 connections at the same time. And the name of the device already suggests it, KNX Modbus TCP Gateway 716 Secure. So the device does support KNX Data Secure and also the secure tunneling connection. So that's so far everything you need to know about the device. Don't worry, we'll take a look at the parameterization in the EDS. But before we do that, let us quickly take a look at Modbus in general, what we need to know. Why do we even need Modbus? Well, in the field of building automation, there are certain devices that maybe don't have a KNX interface, but you want to integrate it in your KNX installation. And there a lot of times those devices support Modbus as a protocol to send or receive data from the device. This can be the case, for example, for electric vehicle chargers, heat pumps, or also energy meters, which you can then integrate with the KNX Modbus TCP Gateway 716 Secure to your KNX system. But how does that work, or how does Modbus work? Well, therefore here we have a little example with an energy meter. This energy meter has a Modbus TCP interface, and if we take a look at the manual of the device, we'll see the different data points this device has in Modbus. And there we can already see two important things that we need to know. So as you can see here, we have the different data points. So starting with the voltage up to the current and so on and so forth. In the first column, we can see the register number. And that's basically the ID of this specific data point on this specific device. So on the register number 1, we can get the data from the voltage. On the register number 2, we get the data from the current or about the current. And in the last column, we can see the data type. So here in this case, we can see input registers and discrete inputs. And you maybe already know it from KNX. There we have a lot of different data point types that KNX is offering us. In Modbus, that's pretty straightforward because there we only have 4 different data types. Those are discrete inputs, coils, input registers and holding registers. The difference? Well, that's basically the size, so either 1 bit or 16 bit in total or 2 bytes, and the access rights to it. So is it a read-only value or is it a read and write data point or value? So you can see a discrete input has a size of 1 bit and is read-only, so it represents a digital input. On the other hand, a coil is readable and writable, and so therefore it represents a digital output. Same applies for input and holding registers. However, there we have analog values with a size of 16 bit. There are no other data types in Modbus. So the analog values only have 2 bytes. Well, I'll come back to that shortly. So what we need to know so far, we have the register number and the data type. And from that we already see what we can do with this data point. However, in Modbus we need an additional information. This is something we can also see in the manual of a device, the so-called function code. With the function code, the master device, or in our case typically the gateway, specifies what it wants to do with this specific data point. Does he want to read the value or write the value? And here you can see the most common used function codes in Modbus. So you can see we have a function code for reading one or multiple registers. We have the same for writing, and we have additional function codes for writing multiple outputs. So here you can also see that for each data type we have a specific function code. And this already makes it a lot easier than it maybe, first of all looks if you see those function codes. Because here a lot of work is already done within the gateway when you specify the data point and the data type. However, you should know which function codes are supported by the slave device, because maybe a device doesn't support reading or writing on multiple registers at the same time. Don't worry, we'll take a look at that in the setup process of the gateway. So let us take a look at a little sample manual. So here you can see, again, we have our energy meter. Again, we have our Modbus registers. So here in this case, on the register number 0, we have the current on phase A and the data type is input register. So it's an analog input. Then we have the current on phase B, also an input register. However, what you can see is that Modbus register 1 isn't used because the current on phase B already starts with register number 2. What's with the number 1? Well, therefore we have to take a look at the second column, and here we see that the current in phase A and phase B needs 2 registers. So in total we don't have a 2-byte value but a 4-byte value. One input register is 60-bit or 2 bytes, and so therefore the whole information of the current in phase A is 2 registers in total, and so therefore 2 times 2 bytes is 4 bytes. And that's something that you oftentimes see, for example, for floating point values. And here we have to bear in mind some additional informations which we also get from the manual. Why is this important? Well, here it's important how this data is then sent to the gateway. Let us take a look at a little example. So here we have such a floating point value, and as you can see it has a total length of 4 bytes. So starting with byte 3 all the way to byte 0. Or you can also see the bits 31 up to 0. And now here the question is, which data is received first in the data stream? So when the Modbus TCP Gateway sends a request, in the response from the energy meter here in this case, it will receive first of all the values in register 0 and then in register 1. And here it's now important how the manufacturer of the energy meter in this case splits up those 4 bytes. What's typically being done, or what I see oftentimes, is pretty straightforward. First we get byte 3, then byte 2, then byte 1, then byte 0. So here you can see that the high byte, so byte 3 and byte 2, those bytes with the higher meaning values, is being sent first. So high byte, then low byte. However, a manufacturer could also decide to change things up. So here you can now see in the first register is byte 1 and byte 0, and then byte 3 and byte 2. So here we have low byte first and then high byte. But sadly that's not all, because we can even mix it up a little bit further. Until now we know the term high byte and low byte, and now we also have the terms MSB and LSB. What is that? MSB stands for most significant bit and LSB for least significant bit. And this specifies which bit is sent first in the data stream. Most significant bit is what you can see here. In the first register, as the first bit, we get bit 15 and then all the way up to bit 0. In the register 1, we get bit 31 as a first bit and then bit 16. So as you can see here, we have now in this specific case low byte first and most significant bit first. So the low byte is sent first, byte 1 and byte 0, but inside of it we have most significant bit first. And you maybe have already guessed it, it could also be mixed up again. So here in this example we can now see that the least significant bit is sent first. So bit 0 to bit 15 and then bit 16 to bit 31. As I already mentioned, my personal experience is that manufacturers typically use high byte first and most significant bit first, so high byte and MSB, but this is not a specific standard because each manufacturer can change it the way he wants it to have. So therefore it's really important to take a look at that in the manual of the device, which we'll shortly do, because yeah, that's already what you need to know about Modbus so that we can start to set up the gateway now. And so therefore I'm now here in the EDH6 and I have the gateway already added to my little sample installation. As you can see here, I have imported the gateway or added it to my topology. And what we can see so far is that first of all, we don't have any group objects because we have to parameterize the device. And therefore we go over here into parameters. And first of all, we see the typical Weinzierl description page where we can see some information about the device, the wiring scheme, etc. Next up, we have some general settings, like for example, if the programming mode can be activated via the buttons on the front, if you want a heartbeat signal, etc. And then we can already see the Modbus settings. But before I will enter the informations there, I first of all want to give the device an IP address. And this is not done via the parameters here, but instead via the properties window on the right hand side. So here you can see I have the IP field. So here I can either say I want an automatic IP address via DHCP or I want to use a static IP address. Now what you can do is the following. You can go ahead, set it to DHCP, then program the device, so download all. Now I have to press the programming buttons. And now what we should see is that inside of the EDH6 we can then see the IP address that this gateway uses. So now that the download is finished, I can go back to the properties and you can see now here the assigned IP address that the device got via DHCP. Now another option would be to simply check your KNX interfaces, because as you can see here, we have the KNX Modbus TCP Gateway 716 Secure over here that we can now use as a programming interface. So that's how you can set up the IP address of the device. But now we want to get some information of a Modbus device, and this is when it comes to the Modbus settings. So here we can now choose the mode, so either the gateway is the Modbus master or the Modbus slave. In this video we will stick to using the gateway as a Modbus master, so therefore I leave it here. Then you can see here we have the settings of MSB or LSB. Now here in my case I use MSB, why you will see in a minute. Then we have the register address, if it's based on a 0 or if it's based on a 1. That's also something that not every manufacturer does it the same way, and because of that you can set it up here. This simply means, does the Modbus registers start with 0 or start at the address 1? Then when we can specify how many slaves we want to have, in my case only 1, and here we can set those slaves now up. So here in my case I have an energy meter that is on the IP address 192.168.2.71. I want to use the port 502. We don't want to use a slave address in this case. What does the slave address mean? Well, the slave address is typically something that comes from Modbus RTU, because in Modbus RTU we don't have an IP address with which we can address the devices. Because of that, we need another solution for this, and this is the slave address. So in a Modbus RTU, network, each device has its own slave address. Why do we need it now in Modbus TCP? Well, that's pretty straightforward, because you could use this gateway here to connect it to a Modbus TCP to RTU gateway, and then you need the slave address here to specify which Modbus RTU device you want to send the requests to, that sits behind the Modbus TCP to RTU gateway. Now, obviously, you could also simply use the KNX Modbus RTU gateway from Weinzierl in this case. However, this is why we have the slave address setting here. I leave it to disabled in this case because I don't need it. Sometimes, however, you have to check if your device requires a specific slave address, because otherwise maybe it won't answer to the request, so an error code is being generated. Next up, we have the request settings. So time till next request, time till next cycle is set here to minimal, which is fully sufficient here in this case. We can then specify if we want to enable multi-read requests. If this is disabled, this simply means that for each register, an own request is being sent. Because we saw with Modbus, we could also read out multiple registers at the same time. And this is something that I specifically have to enable. This is something we will see in a minute why that is the case. Then we basically have the same settings down below here. So if we want to use the function code 5 or 15, 5 means we want to write to a single register, 15 means to multiple registers, and the same applies here to those word registers, so the analog outputs. We can also enable a diagnostic group object with which we can see on the KNX side if a communication is established or not. So these are the general Modbus settings. Until now, we haven't set up any data point. We simply have set up our slave and some additional settings on how we want to communicate to this slave. And now before we go ahead and set up the data points, I want to show you a personal trick that I use when I work with Modbus TCP devices. And this is that I typically use a Modbus master program with which I can directly send Modbus requests to the devices to test if everything works as intended. In my case, I use the program qmodmaster, which is linked in the description down below. So here you can see the program qmodmaster, and what I want to set up is first of all the connection, and this is the IP address of my energy meter. And then in this case, it's important to set the slave address to 255, which basically means the same as disabled in the parameters of the gateway that we saw here. Then the Modbus mode obviously is Modbus TCP. To that I'll come back in a minute, and another thing that I need to set up is here under settings. My device is starting with 0, the register, so the same as here, 0 based. And we have big endian, which basically means most significant bit first. So with that set up, I can start to read out some data, and this is, as I already mentioned, the informations that we get from the manual of the device. So first of all, on this page here, you can see what we saw earlier in this video. We have high byte first and then low byte. This is what this page means here. So you can see on byte 26 we have the high byte, and on byte 27 we have the low byte. So this is basically how the data stream then works. And inside of these bytes you can see we have the most significant bit, so bit 15 first and then bit 0. Now don't worry, this simply is an error here in this manual. That's definitely most significant bit first, and here we have the least significant bit. So therefore, let us now read out some values, and I want to read out those floating point values. And here what we can see is, first of all, the register address is 4096. We want to read 2 registers for this data point, so conductor voltage to neutral on the first phase. And here on top you can see the function code that we need to use, function code 3. So let us set that up. So we want to use function code 3 read holding registers. We have the address 4096, and we want to read 2 registers at the same time, and the data format was float. So with that set up, I can connect to the device and send a request, and we can see we get the value 234. If I add the precision here to 5, we can also see the floating point value. So this is how I typically test my Modbus devices before I start to enter them in the parameters here. Because what we could also see with this tool here is that if I change it here to number of register ones, which would mean that we don't support multi-read requests, we can see that here we get an error. Why is that the case? Well, you have to bear in mind, here in this case we read out a floating value which needs 2 registers. Now if we would have set it up to a single read request, so disabling this multi-read requests, it could occur that the TCP gateway sends a request to the first register, then gets an answer, then sends the request to the second register, gets the answer, but in between we have a little time delta, and in this time delta the value could change, and then those 2 registers aren't complying to each other and we would get a wrong value. And so therefore this is the case why this energy meter here in this case doesn't support single read requests. So we have to enable it here. So that was my little tip on how I work with Modbus TCP devices for the first time. And now we can really start to edit the data points that we can do here. Now here you have to bear in mind that we have up to 250 data points, and here we have blocks of 10 data points at the same time that are all for one specific slave. So if we would have multiple slaves, we can only set up those data points 1 to 10 to slave 1, then slave 2 would be, for example, 11 to 20, and so on and so forth. Now let us set up channel 1. The first thing that you set up is the data point type that you want to have in KNX. That means here in this case we read out a floating value from Modbus. And in KNX, for floating values, we have 2 different types of data point types. We could use the DBT9 that has 2 bytes, or we could use the DBT14 that has 4 bytes. Remember, in Modbus, the value itself spans over 2 registers, so the Modbus data size is 4 bytes. However, this isn't important here for this setting because the Modbus TCP gateway will convert it to the data point type that we set up here. So I can do the following. I can set it up as a floating value with 2 bytes in KNX. So DBT09, we have the description, voltage phase 1, Modbus to KNX. We want to send the value on change. For example, if the voltage changes by 0.5 volts. And now here we have to set up, do we have a single word register or a double word register? Which we have in this case because we have 2 registers that we need to read out. And so here you can see the setting, high word first or low word first. We saw in this case we have the high word or high byte first. Then we specify the type on the Modbus register, which was a floating value. We could use a scaling factor, in my case I don't need it. And we specify the function code, and here we can only choose between function code 3 and 4 because we read out the analog. And so therefore those are the only ones that apply to this. And in my case I need the function code 3 on the address 4096. And that's basically how you can set up the data point. Now let's set up a second data point to show you that I can also use the 4 byte value. So I could use the DBT14, float 4 bytes, voltage phase 2. Again, it's Modbus to KNX. On change, it's a double word register. We have high word first. Then in Modbus, we have a floating value. I don't need a scaling factor. I want to use function code 3. And the next address was 4098. Just to double confirm, here we have 4098. And if I go over to the group objects, we can now see that we have voltage phase 1 and voltage phase 2. One has a data size of 2 bytes in KNX and one has 4 bytes. I quickly hook them up to a group address. So I have connected them to group addresses. I can download everything and head over into the diagnostics. And here we should soon see the values that were read out by the Modbus TCP Gateway. So here you can see we have voltage phase 1 with 234 volts and phase 2 with 235 volts, here with a little bit of more information, because here we have a 4-byte value and here a 2-byte value. However, it works just as intended. So what you should bear in mind is that you first of all take a look at what you need in KNX. So for example, if you want to display the values on a touch display, you should take a look at the touch display, which data point type it needs. So that's now how you can set up those data points. However, maybe you've already seen it, here on top we have a DCA. And with this DCA, it's pretty simple to mass edit those values, because with the DCA we can do the following. We can export the data from the EDS, so the settings that we set up in the parameters. So you can see here energy meter and here the individual data points. And what I can do is that I can save this then to a file. This is a simple JSON format, and edit it with any editor that I like. That's maybe sometimes faster than setting it up via the user interface in the EDS. Or what I have already done is that I have already created a template for my energy meter that I can simply load from a file and import it into the EDS. And besides that, Weinzierl also offers you some templates on their website, so check the link out down in the description below. So what I will do is that I will load it from the file. So I have selected the file, and if we take a look here, we can see I have more data points already set up. And then I can go ahead and import the data here to the EDS. Now I will get a little information that obviously my existing configuration will be overwritten, so I say yes. And now this takes a little bit of time. And after that, you can see in the group objects we now have 15 objects. And so that's basically how you can mass import those data points. So the last thing that I want to take a look at is, besides those data points, the TCP Gateway also offers a DPT converter. We sort of saw it already when we configured the data points, but here it's a little bit more complex, because here we can basically convert any data point type into any data point type. This means that first of all you specify the input type, so for example a 4-byte floating value, and now be careful, this is now the KNX data point type, which you see here, DPT14 for example, and then I can convert it basically in any data point type that I want. So I can convert it in a 2-byte value, a 1-byte value, and even as a 1-bit value. So for example, I could create sort of a threshold behavior that when I say, for example, the voltage is higher than 235 volts, I want to center on, otherwise I want to center off. And so there you have another 100 of those converters which you can configure the way that you want it. So for example, I could also convert a floating value into a signed 1-byte value, and in between here, for example, then we have a scaling factor. And so that's basically how you can set up the Weinzierl KNX Modbus TCP Gateway 716 Secure. I hope that this video was helpful. If you have any questions left, don't hesitate to ask via the comment section down below.